Hello dear students, in this video I will continue with the 5th unit probability. Here I will discuss about events, different types of events, and then what is probability, and I will also solve the questions of exercise 12.2 from chapter 12 of class 11 applied mathematics by Aggarwal. First we will see what is an event. Event is nothing but it is which is associated with a random experiment, and it is the set of one or more outcomes. So we can call event as a subset of sample space. Now say for example, if the random experiment is tossing a coin, then the sample space will be, it will be head or tail. And let us say event is, let us say getting a tail. So we have E is equal to the outcome which is getting a tail. So an event is a subset of the sample space, that is E is a subset of yes. So we have any event, it is a subset of the sample space yes. Now the various subsets of a sample space, it will consist of the sample space itself and the null set. So even the empty set is a subset of yes. Hence an event called the impossible event. So if there is an event in a random experiment which is not at all possible, or in which the outcome is not possible to occur, then such an event is called an impossible event. Say for example, in rolling a die, the event is getting a number more than 7. This is not at all possible. In this case, the event will be the null set. And similar to impossible event, we have another event called the sure event, which means it is the set itself. We know the set yes itself is a subset of yes, and hence this whole set is called the sure event. So such an event is called the sure event. Again, say for example, in rolling a die, getting a number less than or equal to 6, it is a sure event. So here the event is the sample space itself. And now we will see what is occurrence of an event. When the outcome of an experiment satisfies the condition mentioned in the event, then we say the event has occurred. Say for example, if the event is getting a tail, and if we get a tail, then we say the event has occurred. And now what is probability? Basically probability, it is the measure of uncertainty. This probability is a measure of uncertainty. And now there is a way to calculate this probability in a random experiment. It is given by the ratio of number of favorable outcomes to the total number of outcomes. It is probability of occurrence of an event. So the probability of occurrence of an event is given by number of favorable outcomes upon total number of outcomes. This is how we can find probability of an event. Now we will move on to different types of events. The first one is independent events and dependent events. If the probability of occurrence of an event is completely unaffected by the occurrence or non-occurrence of another event, then such events are called independent events. If the events are not independent, then they are called dependent events. And next we have impossible event and sure event. This I have already discussed. If the probability of occurrence of an event is 0, that is, such an event cannot occur, then it is an impossible event. And if the probability of occurrence of the event is 1, then it is called a sure event. And moving on to exhaustive events. A set of events is called exhaustive if all events together consume the entire sample space. Say for example, if the event E1 is getting an odd number when a die is rolled, and the event E2, it is getting an even number when a die is rolled, then we have E1 union E2, it is equal to the entire sample space yes. So such events are called exhaustive events. And next, moving on to mutually exclusive events. These events are nothing but if the occurrence of one event excludes the simultaneous occurrence of other, then such events are called mutually exclusive events. Say for example, if the sample space S is equal to 1, 2, 3, 4, 5 and 6 and E1 and E2 are two events such that E1 consists of numbers less than 4, E2 consists of number greater than 5, then here E1 it will constitute all those numbers less than 4 and E2 will constitute all those numbers greater than 5. Here we can see that E1 intersection E2 it is equal to 5. So here if E1 occurs then E2 cannot occur, or if E2 occurs E1 cannot occur. Such events are called mutually exclusive events. And next we have complement of an event E. Complement of an event E is nothing but it is the set of all outcomes of the sample space other than the outcomes occurring in this E. It is nothing but it is E noted by E bar or E complement or E dash. And probability of this E complement is 1 minus probability of E. And then next we have event A or B. Event A or B, it is nothing but the event is the union of events A and B. And event A and B, it is the intersection of A and B. Then we have event A not B, it is A minus B, or it is equal to A intersection B complement. So this is event A not B. So these are various types of events. And now there is another set of events which are mutually exclusive and exhaustive. Let us take let S be the sample space associated with a random experiment. Then the events E1, E2, E3 up to etc. En are said to be mutually exclusive and exhaustive events if E1 union E2, the union of all these events constitute the sample space and the intersection of any of these events, it is a null set. And EI intersection EJ equal to phi where I not equal to j. Here we have no two events are having common outcomes. If this is the case, then those events and their union constitutes the sample space S. Then such events are called mutually exclusive and exhaustive events. And now moving on to exercise 12.2. The first question, give an example of an impossible event. This I have discussed already. And then next one, give an example of a sure event. Say for example, if the event is getting a head or a tail, when a coin is tossed, then it is a sure event. The third question, a coin is tossed, write its sample space and all possible events. So for the third question, when a coin is tossed, the sample space is head and tail. Now all possible events consist of all the subsets of S. So the events are the sample space itself, then getting a head, then tail, and then the impossible event phi. Next question, consider the experiment of rolling a die. If A be the event getting a prime number and B be the event getting an odd number, then write the sets representing the events. All these are given. So first, the experiment is rolling a die and A is the event getting a prime number. So the sample space is 1, 2, 3, 4, 5 and 6. When a die is rolled, the various outcomes are 1, 2, 3 till 6. A is the event getting a prime number. So A is, the various prime numbers here are 2, 3 and 5. 2, 3, 5. And then B is getting an odd number. The odd numbers are 1, 3 and 5. So 1, 3, 5. Now we will do each of these. A or B, it is equal to A union B. You know how to find union of two sets. So A or B is 1, 2, 3 and 5. Then the next one, A and B, it is A intersection B. A intersection B is 3 and 5. Because only the outcomes 3 and 5 are common to both events A and B. And then the third one is A but not B. So it is A minus B. So it is A minus B will be 2 because the outcomes 3 and 5 are there in event B. So A minus B is only 2. And then the fourth one is not A. Not A is all those outcomes in the sample space which are not in A. So it is A complement. So it consists of 1, 4 and 6. Next question, a coin and a die are tossed. Describe the sample space and the following events. The first one is, first let us write the sample space. So a coin and a die are tossed. So the various outcomes are, we can get either head or tail. So the first can be head 1, then head 2, head 3, head 4, head 5, head 6, tail 1, tail 2, tail 3, tail 4, tail 5 and tail 6. So these are the various outcomes, or it is the sample space. The first subdivision, getting a head and an even number. So getting a head and an even number will be H2, H4 and H6. So A equal to H2, H4 and H6. Then the second subdivision, B is getting a prime number. So B will be, with head the prime numbers are H2, H3, H5 and with tail the prime numbers are T2, T3, T5. So that is B. And then C, we have getting a tail and an odd number. So that will be T1, T3 and T5. So C equal to T1, T3 and T5. And then the fourth subdivision, D. D is getting a head or a tail. So getting a head or a tail will be all these. So D will be H1, H2. It is the entire sample space. T1, T2, T3 till T6. Now answer the following questions. Are A and B mutually exclusive? Now here it is asked whether A and B are mutually exclusive. They are not mutually exclusive because A intersection B is not equal to 5. There is one outcome which is common. So for this first subdivision, no, since A intersection B equal to H2. It has to be 5. And then B, are A and C mutually exclusive? Are A and C mutually exclusive? They are mutually exclusive because A intersection C is equal to the null set. The third subdivision, are A and C exhaustive? Here A and C is not exhaustive. A and C, A union C will not give the entire sample space. So C is no, since A union C not equal to yes. And then we have are A and D exhaustive. Here we can see A and D are exhaustive because D is the entire sample space. So A union D will be yes. That is the sample space. A union D is equal to the entire sample space. So A and D are exhaustive. Next question. Two dice are thrown. If E is the event, both dice come up with the same number, and F is the event, product of the numbers on the two dice is odd. Then describe each of these events. So E is first, let us write the event. So E is the event. Anyway, the first subdivision is E. So E is the event, both dice come up with the same number. So event E will be 1 1, then 2 2, then 3 3, then 4 4, 5 5 and 6 6, because these are the events that come up with the, these are the outcomes that come up with the same number. Then the second one is F. Product of the numbers on the two dice is odd. So this can happen for 1 1, 1 3, 1 5, and then 3 1, then 3 3, 3 5, then 5 1, 5 3, 5 5. So these are the various outcomes. That is the event for product of the numbers of the two dice is odd. This is F. Then this third subdivision, E or F. E or F consists of E union F. So E union F will be 1 1, 1 3, 1 5, then 2 2, then 3 1, 3 3, 3 5, then 4 4, 5 1, 5 3, 5 5, then 6 6. So this is E or F is E union F. Then the fourth subdivision, E and F will be E intersection F. So the various outcomes common to E and F are 1 1, 3 3 and 5 5. Then the next subdivision, E but not F. E but not F will be E minus F. So it consists of all those outcomes of E but not in F. So all those outcomes of E but not in F are 2 2, 4 4 and 6 6. Because the other outcomes 1 1, 3 3, 5 5 are there in F. So E minus F consists of these outcomes. The next question, from a group of 2 men and 3 women, 2 persons are selected. Describe the sample space of the experiment. If E is the event in which 1 man and 1 woman are selected, then which are the cases favorable to E? So here, from a group of 2 men and 2 women, 3 women, 2 persons are selected. So let us take, let the persons be M1, M2, W1, W2, W3. So let the 2 men and the 3 women be denoted by these symbols. And here the experiment is 2 persons are selected. So the sample space will be M1, M2, M1, W1, M1, W2, M1, W3. So from M1, M2, W1, W2, W3. And then again from M2. M2, W1, M2, W2, M2, W3. Then W1, W2, W1, W3, and finally W2, W3. So this is the sample space. And now coming to the event E. If E is the event in which one man and one woman are selected, then which are the cases favorable to E? So E consists of the event in which one man and one woman are selected. So the outcomes favorable to E are M1, W1, M1, W2, M1, W3, M2, W1, M2, W2 and M2, W3. So all these outcomes are favorable to E. So it has M1, W1, M1, M1, W2, M1, W3, then M2, W1, M2, W2 and M2, W3. So these are the outcomes favorable to event E. I hope this video was useful for you. Thank you for watching.